Hi and welcome. This time around we have another interesting project from my customers over at the laser welding place. And they sent me this part, which is really an interesting part. They've obviously welded these two pieces together in the center here. And what they need from me is a vacuum fixture that will check a vacuum when these two ports are attached to the vacuum itself to make sure that there aren't any leaks in the weld. And I'm not sure what they use to test a vacuum. I have heard of using things like helium test or hydrogen test for vacuum leaks, and you got a detector in the vacuum path. I'm not sure how they're going to do it, but I need to make a fixture to hold this. They sent me this fixture as an example of a different vacuum fixture they had used in the past, but clearly that's not going to work for this. They sent me drawings for these guys here, but unfortunately the drawings weren't accurate. I think the only ports that are open to the inside is this one and this one. These are all mounting holes for something. So I need to figure out some measurements here because I printed this scale drawing. As you can see, it fits there nicely. But when I line it up, the hole placement based on their dimensions, clearly this hole diameter that I chose here would be the minor diameter of these 7/16 20 threads. And you can see that clearly that spacing is much larger, that is not going to line up. So I have to figure out how far from here and how far from the side these holes are, because I need to make the fixture and it needs to be dimensioned based on that. So I've got a method for doing that. Let's do that first. First step was to find the internal diameter or the minor diameter of the threads. Now I looked up in the machinery's handbook, but these threads don't meet that spec exactly. So I found a pin that is a very good fit for both of these, so that hopefully averaged they're accurate. It's a little bit looser on the top one, pretty snug on the bottom one. And this is 390 thousandths, so I made a notation of that. So the first measurement we're going to get is try and get the height of this pin off of the bottom here. And I guess if I want accurate measurements, just so you know, nothing here matters this much, but I'm going to take my precision ground flat stone and stone the bottom to make sure there aren't any burrs. Okay, so I have the indicator zeroed here and the indicator zeroed here, and try to get as repeatable as possible. It's off by a couple tenths, not repeatably, within a couple tenths. So I've got to know the limitations of the rack and pinion on this Michitoyo height gauge. But in any case, now we're going to come up and we are going to find the height. So here's the high point. And then I'm going to dial that to 0 here. And that gives me, for the top of the pin on the flat side, 0.639. And I'll just come back to 0 here. Very good. So let's go up to 0.639, 5, 6. Oops. There's a little bit of angle. Those threads are not all a perfect straight line. So 0.642. Okay, and I made note of that. Now we're going to rotate to this side. And first I'm going to stone this guy. Make sure there are no burrs. These precision ground flat stones only take off burrs, high points. And here we have 0.831. So I know that I have the right location for this guy, and then I'm putting the right pressure on the part when this guy is at 0, and then I can just read the value off here. But to double check this, we can go back to 0 again. Oops, too far. Looks like that shifted, so we'll set a new 0 here. This rack and pinion is not wholly repeatable, unfortunately. Okay, that repeated. So let's go 1, 2, 3, 4, 5, 6, 7, 8. Ooh, now it's 0.7 something. Boy, that was way off. Point 7.732. And I'm going to double check my reading again, and we will go from there. Then what I can do, I know that this pin is a 390 pin, so I can take that pin and I can divide it in two, and I can find the center point of the circle. Sorry, here on this drawing here. I can take that pin that I know is 390 and I can divide by 2. Knowing this whole thing, I can subtract half and I can get my center height in each direction. And that was the purpose of this exercise. But since it's not repeating, I'm going to try a couple more times just to make sure I got the right value. If the absolute measurements were more important, then what I would do is I'd build a stack of gauge blocks and I'd just go from one to the other, and I'd use just the normal comparator stand. And that way I would know when I'm right on. So I'd build a stack of gauge blocks, set this to 0, lock this whole thing off, come back and measure this part, and when they're even, then I know that this height is the same as the gauge block stack, and I can get much more precise measurements like that. And I wouldn't use this adjustable stand for that. I'd use a heavy-duty fixed stand for that. Anyways, you get the idea, and hopefully that was useful for you. So now that I got the dimensions from this guy, I made a fixture right here. And originally I was going to make some locating pins that locate in the center of these threaded sections, but the vendor is really concerned about threads getting damaged. So even though I was going to make them out of aluminum, they weren't very pleased with that idea. They said they'd rather just locate it themselves. So they just want to push the part down on the vacuum plate, and that should be all they want. So got a drawing here for the fixture. I've changed the design a bit since I came out with this. So originally it's 3/4 inch stock, and I was going to have the vacuum mounting pin, which is an inch, 1.13 inches in diameter, only go halfway through. Now I'm going to have it go half an inch in, and then just these little holes in the top that let the air out of the part to suck the vacuum are going to be just an 1/8 inch. They're on one side, the other big holes on the opposite side. And so that I can set this pin down in here, I'm going to machine this a little bit long, and then I am going to machine most of the material out except for some little bits around the edges so that I can push the pin all the way in and it'll hit a natural stop. So that's my intention. So let's over the bandsaw and cut this guy out so we can get a little piece of material. Here we are at the bandsaw. Let's start our cut. Three-quarter inch stock. First up, we'll make the post that interfaces with the vacuum machine. I'm not sure what that looks like, but I'm just duplicating what already exists. There's a hole already in the stock, so I'm going to use that because I actually need to drill a hole in it anyways. So first off, we're going to face this guy as usual. And we're going to take some off the outside. We're looking for 1.130. So this is my first cut, and I could have done a much more aggressive cut. This is wasting time. But I sure do like the finish. This hole is not a critical hole. It is a very rough hole. So I wasn't worried about the absolute dimensions of it, absolute concentricity with the outside. As you saw, it wobbled, the drill bit wobbled quite a bit, but that's not going to be a problem. Deburr the inside of the hole. Just going to part this guy off. There we go. Got this guy locked in the vise now. And all I want to do is take an end mill and cut out the whole center section of this so I can basically line the opening up with the two holes that are coming down. You see how these holes intersect? The big circle is this guy. And so these 1/4 inch holes are going to intersect that. So I want to relieve the center section so that the air can be pulled out of those holes, but still leaving some material for this to bottom out on and basically seat itself. So I don't need an exact center, I just need a rough center. So all I did was take this center here and find the middle of this, and pop an end mill in there, set my DRO to 0, go either side and remove some material. Pretty straightforward, not a precision operation. So all we're shooting for here is removing 1/8 of an inch of material. We're going to do it in one pass, and then I'm going to go plus or minus the y-axis a little bit, just based on appearance, to make it easier to line that up. And this part is done. Next up, I'm just going to dimension some stock on the main vacuum fixture, and I'll be right back. Next up, I'm just going to take a skim pass over the top part of this, which is where the silicone pad is going to be that has to make the vacuum seal. We just want to have a flat surface without any imperfections, and there's all kinds of bumps and stuff on this. So we're gonna go down like 5/1000. There's the finish on one side. And deburr this, and I'm just going to skim the other side too, just so it looks nice. Even though I got the outside dimensions of this part within 1/1000th, I'm not using the outside dimensions to locate any of my 3 holes. They're all going to be based off the center. So I'm just going to find the middle of all these, this side and this side, and that will be my 0 reference point for both sides. And hopefully that way all my holes relative to each other will be fairly accurate, although ultimate precision really, again, is not that important. So the center of this guy, the hole, I want to go down 1/2 an inch. But what I don't care about actually is whether that supports this cylindrical part that's going to fit in here. That's actually not important, fortunately. So we don't have to be very careful with that. We're going to bore the outside so that it fits as an interference fit, or I'm going to weld it. I haven't figured that part out yet. Now we're going to go up to the next size. I'm also going to remove a bunch more material because it's a lot faster, obviously, to remove it drilling than it is to bore it. Next up, we're going to bore the hole out to final size. There's kind of a big bite here. giving some more back rake on the cutter. Can already tell it's better. I think we got our size just right. A little bit of a Loctite added to this, and I think it's going to be a nice interference fit. I think it should be vacuum tight. Hopefully I'm not wrong. So next we can just flip this over and drill the 2 holes and then press fit this guy in. This will go in this way, by the way, and these will point towards the 2 holes, which will allow the vacuum to suck from the center hole, suck air out of the hole on top, which is where we're lining to. So there we go, that's the part starting, and I'll just press that guy in with some Loctite. Since the holes I'm going to drill from the other side only overlap this center round section by just a little bit, I thought what I was going to do is I'll take a key cutter and I'll just cut into the side, which will allow a bigger portion of this hole to be exposed to the vacuum, which will be pulling through here. So we're just going to drop the key cutter down there and go sideways and cut into the side on both sides, and that'll just give me a little bit more airflow through there. Not that I think it's going to be a problem, but just in case. I don't know how well you're going to be able to see this, but I'm just going to give it a shot right here. Oops. So you can see this, maybe. You can see the undercut there. So when I drill the 1/4 inch hole through, so we're going to drill our 2 holes. They're off-centered from each other. 0.555 over, 0.197 off the axis. This hole is on the below the axis. This hole's above the axis. There we go, and we're through. All right, so this is essentially done. I just need to make a silicone sheet to go on top of this. In addition to that, I may consider, I'm going to do some tests on some surface grinding aluminum. If you use a silicon carbide wheel, it supposedly works on aluminum if you take light cuts and use a lot of coolant. So we're going to try that. First on a scrap piece so I don't damage this one. This is a very smooth surface, but the cutter was going like this, which would allow some gas to go in along the length there. I mean, I'm hoping the silicone would seal that, but just in case. All right, so I played with the surface grinder, and yes, with a carbide, silicon carbide wheel, I could absolutely do aluminum, and it wasn't loading too badly. But it was hard to get the depth very gently, controlled. So instead, I chose to lap it. So you see there's no tooling marks there, just some very, very fine scratches that are kind of hard to see. Here's the other side, and you can see the tooling marks on there, especially the swirls this way where the cutter went across it. So this is the side that needs to make a seal, and this one was sticking to the sandpaper and surface plate that it was on. So I think that's a pretty good sign. I think we're pretty flat. It's not glass shiny, but I think it's adequate. So next we just got to cut some of the silicone and we should be good to go. I've made a silicone piece. This is fairly thick. This might be too thick, so I might try some of the thinner stuff I've got here. I'll do that in a moment. But in the meantime, I want to press this guy in. It's going to be pressed in at an angle something like this. And I need to preload it with some of the Loctite 380. I hope that'll work. There might be better stuff. Hopefully this will be good. It's got rubber impregnated, so I'm hoping it'll seal. And I'm hoping this guy will go in straight. That's a nice interference fit, I think. I do see it squeezing some of the Loctite out the side over here. I don't know what would have gotten pressurized, to be honest. All right, so here we are at the end. I've cut several different kinds of foam for them. This foam is 1/8 inch thick. This stuff is 3/16. They're both closed cell foam, so even if some of the bubbles are near where you're going through, it shouldn't leak. This one's interesting. This one's got a plastic liner on it, and the plastic liner prevents the material from stretching as much when you're cutting it. This stuff was really hard to cut in a straight line because it deformed as you cut it. Like the cutter moving across it stretched it in the direction you were moving it. So that was interesting. Anyways, I learned a bunch here, and hopefully this project will work out for the customer. Thanks for watching. Hope you find it useful. Hope to see you next time.